Hey guys, today we're looking at parametrics in the calculator, and we did this in class, so hopefully this is just a refresher for you, or if you missed class. So if you remember, a parametric equation is basically each of my coordinates of my points are defined in terms of another variable t, and that usually stands for time. And so if I want to do any of these types of equations in the calculator, instead of having to make tables for everything, I simply go to the mode on my calculator and I change it to parametric, or yours may say PAR, which is short for parametric. And so now when I go into y equals, I see that everything is defined in terms of an x and a y, and they're both in the first one. So I'm going to go ahead and type this into my calculator, and again, I'm going to use this variable button because it makes an x, a t, a theta, it makes whatever mode you're in, it makes that your variable. So I type in 2t minus 1 for my y, and then it gives me some restrictions to put in my window. So I'm going to go to the window, and I'm going to change it so it matches these things on my paper. And so now I have my window fixed up, and I'm going to go ahead and I'm going to press graph. And so I look at this, it tells me make note of my domain and range. So if I look at this graph, I notice that my domain, or where my x starts, it starts at the y-axis. So my domain, or my x, is at 0, starts at 0, whereas my y is starting at -1. So that's my parametric equation. If I was to plot points in between 0 and 4, this is what it would look like. So now it asks me to change the value of the t step. So if I go back to the window, and I'm going to go make that, instead of a 0.1, I'm going to make it 0.01, make it even smaller. And I'm going to press graph. And the one thing that you notice here is this graphed a lot more slowly. So it's graphing slower. And the other thing about it is that my graph actually became a lot more accurate. If you notice, it looks a lot more filled in, like all of the points are actually there. So it's more accurate, it's graphing slower, it's actually graphing more points. So if I change my window and I change my t-step to just be a 1, this would kind of look like what you'd graph on your paper. Instead, this is just graphing every 1. So what changed about it is it's faster, and it's a little less accurate, because instead of graphing from 0 to 4 counting by 0.1 or 0.01, it just counted by 1. So if I change that t-step value, all that does is makes my graph more accurate, or it kind of puts more points in between in there. So if I change my t-min and my t-max values, this is also going to change something about my graph. So instead of having 0 to 4, maybe I want to go -2 to 2. So that's the same amount of points here, but what's going to change about the graph? And if I look, my graph now starts at a different point and it ends at a different point. So if I go ahead and I change this t-min to be at 0 again, you're going to see I started at the same point, but now I ended. And so again, when you are changing your t-min and your t-max, you're telling your graph where to start. So it's kind of like when I looked at my tables when I was doing parametrics, you're just picking the t-values that you're graphing. So when you change these about the graph, it changes where the graph begins and ends. So now we're going to graph a different parametric function, cosine and sine. And if you remember, these made circles. And so we're trying to figure out what's going to happen if I change t-min, t-max, t-step. So if I go back to my window, we're going to see where I'm graphing. Right now I'm from 0 to 2, and then at 0.1. So I'm going to go change that back to 4, and I'm just going to look at the picture. So we have my graph, and if you notice, this is a circle. It should be a circle. It's a little bit skewed because of the window here. But if you notice, it only put a part of my circle. So if I go back and I change this and I make this, let's say 10, you're going to see I still start at 0. Now I've completed my circle, but my graph was still graphing, in case you didn't notice over there. Because if you think about it, it takes a whole 2 pi radians to continue going around. And I still know I'm in radians because I didn't change that on my mode. So if I graphed exactly 2 pi here, then I know I would get just my whole circle, and then it stops. Then if I change my t-step, if I change this to be a bigger number like 1, you're going to notice that I get a very inaccurate graph. It doesn't look like a circle at all. It's just plotting a couple points in between there. Whereas if I change this to be something like 0.01, like we did before, you're going to see my graph goes really slowly and is more accurate. So again, this is the same thing that happened up here. It's just going to be a little bit easier to see the accuracy of your graph. So again, it did the same thing. And then for number 9, again, you summarize. We've just talked about it. Your t-step is going to change how many points your calculator's graphing, so how accurate your graph is. And then your t-min and t-max tells your calculator where to begin and end. So if we're looking, and again, if you're good with these things, you can go ahead and stop. This is the spider and the fly. So when I'm looking at these guys, we're going to graph these two parametric equations and make sure that we change my mode accordingly. So it says change my mode to radians. I'm good. I'm in parametric. And then I'm going to change my, instead of sequential, I'm going to change it to simultaneous. What that's going to do is it's going to make my equations graph at the same exact time so I can see both of them in real time. Then I'm going to change my window. And now I'm going to watch the spider and the fly and see what their motion is. And so my first equation was the spider, so my blue is my spider, and of course I haven't actually typed it in yet. I changed my window. I got real excited about that, and I didn't even type my equations in. But my spider is going to be the blue graph, and my fly is going to be the red graph. T. So let's go ahead and watch it. And so it looks here, it says explore the path of the spider and the fly by using the trace button with the up and down keys. So the one thing that's going to happen here is when I trace this and I'm going back and forth and looking at this, first of all, we have to move to the right to get anywhere because that's the path that it took. And the other thing is mine is going really, really slow because I put my t-step as something small. But the one thing I do notice here is my graphs are intersecting. Okay, my graphs intersect right here at -1.5, 3.5. But if I look at that other parameter right here, for my fly, that fly got to that point at 2.5, where t was 2.5. Whereas if I go up, whoa, I don't know what's going on. Whereas if I go up and I look at my blue graph, and I get over there slowly, because my t is really small. I should have changed it before I started, but now I'm in it. I gotta finish. So when I get to that intersection point of -1.5, 3.5, I see that the spider got there at 0.75 seconds, or 0.75, which means that the spider's not gonna catch the fly because the t was different. When we were looking at it, yes, the lines intersected, but they crossed at different times, and this is thinking about real time. And so they might hit the same spot, but they weren't there at the same time. So the spider was like, well, no dinner for me tonight. Okay, and the last one that we talked about was the race. So the hare's having a fair race with the turtle since he can sprint, not spring, at 24 feet per second, while the very best that the turtle can do is 18 feet per second. The hare gives the turtle a 15-foot head start. Here's the parametric equation. So I'm going to go ahead and type these in. And now they're asking me to find a good window with the t-step of 0.1. Well, I know that the t-min, t-max, that's going to be time. So I'm going to give this race a good amount of time, probably a good 10 seconds, right, because they're going pretty quickly. And then they say my t-step needs to be 0.01, so thankfully I don't have to think about that. Now my x-min and my x-max, this is thinking about the distance that they're going in the race. Well, I know that they're going to start at 0, and then I can kind of guesstimate maybe they're going to go 100 feet. We'll see. We can always change this in a second, and I can change my scale if I need to. Y-min, again, they're going to start at 0, and this is kind of weird because really what this is going to show is just the path of your race. And so if I look right here, the maximum Y I have is 5, and so maybe I want to put it at like 8 or 10 or something like that. So this is just going to show me what's going to happen. So I'm going to go ahead and graph this, and we're going to watch the race. Oh, and the hare is brown, and the turtle is green. And so you can see they're going, and there goes the hare. The hare has won that race if it was 100 feet. So we found our window. And I'm going to be super lazy. Actually, my calculator's still trying really hard to finish what it's doing. So this was the window that I used, if you need to copy it down. And then it says if they race for 50 feet, who wins the race? Well, if I go back to my window and I change my race length just back to 50, and I watch this race, we can see who's going to hit that first point first. There we go. So they hit it, the turtle, the green one hit it first. So the turtle's going to win if the race is only 50 feet. Now if I go back and change that to, again, it's graphing forever. I'm trying really hard. There we go. And if I go back and change it to 75, we kind of have an idea that it's going to be the hare at this point. And then I watch this go one more time. And we see that the hare, the brown one, hit first on that one. So that would be the hare. Now, this next one, they ask you, who is ahead at 3 seconds? And there's two ways you could do this. You could do this with algebra and use the two equations that they gave me, the 18t plus 15 and the 24, and just plug in 3 for each of those. And then that's just math that you can do, arithmetic that you can do on your home screen. The other thing you can do is go into your table and you can go look at where is t equals 3 and go get those x coordinates. So I know that the green one, the turtle, was at 69 feet, where the hare, the brown one, was at 72 feet. So if I look right there, who's ahead? Well, that would have been the hare's equation. So at 3 seconds, the hare was winning. And then finally, at what time did the hare overtake the turtle? Well, again, I'm going to look at the two equations that represent both of these guys. And I'm looking at the x values because the y's are just kind of giving me a position so I can see the race. So I want the hare, the 2, to be bigger than the turtle, or the 1. And so if I'm looking at 24t, I want that to be bigger than 18t plus 15. And now this is just an algebraic inequality that you could solve. Subtract 18t from both sides, and then divide by 6. And then I would know that at 2.5 seconds, that's when the hare started winning. And that's how you can do these type of equations in your calculator.